So our next chapter is basic of electricals polarity. First, energy stored in a battery will give rise to positive and negative polarity. So these are the diagrams like charge. In charge case, holes and electrons are both same at same number of electrons, and holes are same at both sides, positive and negative. And in discharging condition, number of electrons move to other side and number of holes created. And in discharge condition, you can see the discharge state in last diagram. Next one is this material type, like conductors, copper, aluminum, insulators, paper, wood, glass, which do not allow electricity to pass through them, semiconductors, which are lie between conductor and insulator, carbon, silicon, and germanium. Now silicon maximum it is used as a semiconductor in devices. Potential difference and volt. Difference between two charging state called potential difference and measured in volts. 1 unit of charge called coulomb has 6.27 10 to the power 8 electrons. Some voltage referred to EMF symbol E, but this sometime standard symbol for potential difference is V, current 10 ampere. Next, potential difference causes a charge to move between 2 points called electric current and measured in amps. Two circuits are there. Direction of electron flow, it is negative to positive, and in conventional flow it is from positive to negative. Next one is this magnetic field. For magnetic field is created on the side of conductor, for example like speaker, transformer, relay, motor, electromagnet. Field is created on the sides of conductor. So our next point is this resistance. When voltage applied, temperature of conductor will rise. This happens due to current flowing against opposition in conductor material called resistance and measured in ohms, omega. Resistance of copper wire is 0.018 ohm per square mm of 1 meter length. Next is circuits. The current that flow referred to as load current. When current path broken called open circuit. If fault occur, current flowing in closed path called short circuit. In short circuit, current is very high. We generally use a fuse to protect against this. Circuit breaker and fuses. Next, fuse protect against excessive current and reduce risk of fire due to overheating of conductor. HRC fuse example. Okay, then circuit breaker, mechanical device that open circuit under fault condition and can be reset when fault is removed. Ohm's law, you already know, V I equals to V upon R equals to V upon A, P equals to VI in true power, and P joule equals to I square R. In this, electrical energy transformed into thermal energy is known as joule heating. Energy watt hour, power into time. Example like 60 watts you are using 5 hours, then it will be 300 watt hour. 1 unit equals to 1000 watt hour. DC and AC. DC fixed polarity, steady, variable magnitude. DC to DC converter example. And AC polarity reverse regularly, magnitude varies constantly. Example transformer. So next one is this characteristics of AC. VRMS, power consumed by resistive load. V average sum of the voltage divided by time to determine the behavior of transformer and motor. V average may be above and below true RMS. VRMS equals to Vp upon under root 2 0.707 into Vp, or VRMS equals to Ip upon under root 2 0.707 into Ip. I is the current, peak current. Okay, Vp is the peak voltage. Frequency. Next, number of cycles per second. It is unit is hertz. So standard grid on main supply frequency in India is 50 hertz. Next is harmonic distortion. It causes distortion in waveform, generally sinusoidal at high frequencies. The harmonic content will occur in waveform. IEEE 519 mention limits of total harmonic current injection from generating station. Power factor is a formula true power upon apparent power. True power travel in one direction and measured in watt. Amplitude is there, V and I is shown. So from 0 it is started, it is volt, and the bottom side it is current. Lower power factor results in higher current. If power factor is low, means current is higher. Next one is licensing requirement. Draft IEC 62548 above ELV. ELV means extra low voltage, 70 volts ripple free DC. Licensed and experienced person will work on grid connected PV systems. IS 875.3 minimum design load on structure. IEC 62305 lightning protection. IS 732 wiring rules. IEC 60364 low voltage electrical installation. Draft IEC 62548 design requirement for PV system, PV arrays. IEC 62446 O&M and documentation. Impedance, resistance and reactance in AC circuit. Reactance is consists of inductance and capacitance. In ideal AC circuit, maximum resistance and minimum reactance. And this last in DC circuits, P equals to VI. In AC circuits, VA means MP apparent power, V into I, V into I. Power factor, PF equals to cos 5, cosine angle between voltage and current. In AC circuits, reactance of a load cause a phase shift and current with respect to voltage applied, means phase shift is there. It results in energy supplied to the load is greater than energy recorded on wattmeter. So measure of power supplied to an AC load is apparent power, means we have supplied the power and it is measured, it is called apparent power. Pure resistive load, heater, incandescent lamp will not cause any phase shift because power factor is equals to 1, means 0 degree equals to 1 cos 0 degree. True power equals to IRMS into VRMS into power factor. Inductive lagging power factor, example motor, transformer, blast. Capacitive leading power factor provided by capacitors. In power factor, true power upon apparent power, and true power is also measured by AC wattmeter. True power denoted by W and apparent power will be VA.